Main class is thread. Okay, threads by extending thread class by implementing runnable interface, multiple threads. Very good, excellent. Exactly in the same order we have discussed. Okay, main is also a thread, and also we can create threads by using in two ways. We can able to create a thread, that is by extending a thread class and by implementing runnable interface. And the runnable interface is having how many methods? How many methods it is having? One thread, which is, what is the method? What is that method? Run method. So that I could able to implement that run method. Okay, yeah, fine. So let us not waste much time. So directly we can go straight away with the next concept. That is this screen clear? Is that screen clear to you? Okay. See, did we discuss this program? We didn't know. That is, did we discuss priorities? Actually, priorities, I already told you that breaking. Is my voice breaking? I have full network now. Is my voice still breaking? Can you check right now? Is it okay? Is my voice okay? Shall I continue? Sometimes it is breaking. Lot of disturbance. Okay. Can you check right now? Is my voice okay right now? Fine. Yeah, thank you. See, okay. So we have priorities. We have many priorities, like minimum priority we have, and there is an echo, means actually I am inside a room. Yeah. Max prayer. We have some. Can you check my voice right now? Is it still like that? Is it fine right now? Better. Yeah, fine. Okay. See, these are the priorities we have seen. Some of the priorities we have seen. Let me tell you what are all the priorities. Okay. Okay. It might be long. See here. See, what is priority? An integer value that specifies a relative priority of one thread to another. That is, we can distinguish, we can tell, we can specify a particular priority on each thread. Okay, so we have three types of priorities on threads, that is minimum priority, max priority, and normal priority. And also we have seen that these are the static variables, these are the static attributes actually. Okay, and final and static variables, these are final and static variables. And the minimum priority is 0, normal priority is 5, and the maximum priority is 10. Okay, understood? And but set priority, there are two methods, set priority of priority, because as you pass any priority of your choice from 0 to 10, you can able to set priority of your choice based on your choice. And also you can get the priority, you can use the method get the priority, so that you will find out the what priority the thread is working, on which priority the thread is working. So these are, and listen very carefully, as you just read these two lines. Thread scheduler may give, thread scheduler Just give me a second, guys. Just give me a second. Yeah. Okay, let us start again. So these we have three types of priorities: min priority, max priority, and normal priority. And I already told you that. And listen very carefully. You just read the two lines first. You just read the two lines first. Okay, what are the two lines you have to read? Thread scheduler may give preference to high priority thread while scheduling the threads for execution. That is, it may give, it may give or may not give. Okay, that is, if I am setting a priority of 10, that is, the thread scheduler may look at that particular thread or not. It depends. Okay, it is not a rule that of course there is a high priority thread, I always has to look at that. No, sometimes it may give, it may not give. Okay, the thread priorities are only to influence the thread scheduler, only to influence the thread scheduler, but it is not real. We cannot rely on them. Okay, that you should keep that point in your mind. Okay, understood? No. So in this program, what we are doing? See this very carefully. In this program, how many classes we have? We have only one class. We have only one class. Yes or no? That is demo 5 class, which extends from thread. And even main method is also in this class. Okay, main method is also in this class. And this demo 5 is my thread class right now, as it is extending from thread class. Okay, now I am creating a. What is T1 here? What is T1 here? Can you please tell me? What is T1 here? What is T1? T1 is a what object? What object? Which object? Thread object. It's a thread object right now. Okay, I am just printing this. I am just printing the thread object. Okay. Okay, I'm just printing the thread object so that the toString method is going to be executed once. And I'm actually at this time, what would be the priority? At this time, what would be the priority? If I print that thread object, which priority? Normal priority. For every thread, it's a normal priority basically. But after that, what I'm doing, I'm setting the priority to 10. Okay, I'm setting the priority to 10 and start. And method start I am using. Okay, as soon as I start, do I need to call the run method? Do I need to call the run method? No, right? Yes? No. Right. Very good. And one more thing, guys. This part of the code is under which under which thread control? This part of the code under main thread. Very good. This is under main thread control. Okay. What is there in main thread? Main thread priority thread dot current thread. So what is this method is going to do? Thread dot current thread. What this method is going to do for you? It will give you the. It will give you the. Priority current thread method, what it is going to give you here? We already discussed. We have already discussed. It will give you the reference of the main thread, no? Reference, very good. It will give you the reference of the main thread. On that main reference, I am calling the get priority method. Understood? From here to here, I am getting the reference of the main thread. On that reference, I am calling the get priority. So you will be getting 5. Okay. And here I am printing what I am printing. Some code I am just printing because I just want to show whether which thread is going to be called first or second or something. Okay, child thread or main thread. So in the run method, what we have? Child thread priority, thread dot current thread. Okay. Dot get priority, thread dot current thread dot get priority. So here thread dot current thread method will give you the reference of which thread, will give you the reference of which thread right now. Can you please tell me that? Guys, hope you can listen my voice clearly. Yes, I just asked you thread dot current thread method here in the run method will give you the reference of which thread. I am asking. Child thread. Yes or no? Is it lagging? Because I just asked it before 2 minutes. Okay, fine. So it is giving the reference of the child thread dot get priority. So what output you can expect over here? What output you can expect? Can you please tell me? Get priority, child thread priority. What would be your child thread priority at this stage? 10. Okay, guys, everybody has to reply. Not only Anil, Jagadish, and etc. Some of the students who are regular to respond. Everybody has to respond. Okay, Jahnavi, can you please leave one more message in your group because only 40 students were joined. Because I'll finish this thread concept today itself. Okay, so that I'm going to cover many concepts today. So if they miss, it would be difficult for you to understand later. Just leave one message, and it is a very strict thing because I'll consider these absentees in the next unit test also. I'll consider these absentees. I'll look at these absentees numbers. Okay. Please leave one message. Do we have swings chapter? What is that? Unit 5. Are you asking about? Unit 5? Yes, of course, but it's not that much. It's not whatever the important topics only we'll discuss. The lab programs which are having the concepts of Unit 5, them only we'll discuss. Not each and every topic because they are least bothered and that much not important. Okay. Okay, Anil. Okay, fine. See. Right. So let me execute this program. Did you understand, everybody? Let me execute this program. Shall I execute? Remove. What you got? See, main thread. Initially, I just printed T object. Let me set this once again so that yeah, look at this, how we got the output. Initially, this is from this statement, T1. If I am printing T1, I am getting thread 0 because it is the child thread which I created. So the name of the thread initially is thread 0, and the 5 is the normal priority when it is actually at the starting, that is new state, and main is it belongs to main group. Okay, and main thread priority 5. Actually what has did this statement got executed even before this. Did you observe that? Understood now? So we cannot expect that which one main thread is going to be executed first or child thread is going to be executed first, because I already told you actually the priority of the which thread has the highest priority. Which thread has the highest priority among between main thread and the child thread? Which thread is having the highest? Demo 5 means what? Child thread. Okay, you need to answer that it is a child thread. But still, what happens? This is got executed first. And then this is got executed, and then it got child thread got priority got printed. That shows the priority may influence your thread scheduler, but we cannot rely on that. That statement is true for you have to be considered. Okay, I'll just execute once again. See, this time understood? No, even though we have given priority, but it is not consistent. We cannot rely on them. Okay, understood? Not demo 5 program, everyone. Okay, understood? Right. See, now there is a join method. We are going to discuss right now. Jahnavi, did you give a message? Did you leave a message in your group? Yes? Right. Okay. See, here we are discussing a join method. Actually, join method, what it is going to do is, the method join is called on which thread that thread is going to be finished first, and then the next thread is going to be executed. That is, listen very carefully. Here, as usual, we have a thread class, that is which is extended from thread. That is, my thread is a thread class, and demo 6 is a class which is a test class. In that, I am having a main method. Okay, and here what I am using, why did I use this throws of interrupted exception? Throws interrupted exception, why did I use that? Because I just used what method, what statement I have used here, what method I have used. That is what reporting. Yes, exactly. Why did I use that? Or because I used what method? Look at the program. Very good. Sleep method. Not join, Rohit. This is because of sleep method. Even we discussed in the previous programs also. Whenever you might have used sleep method in your program, that sleep method will raise an exception of type checked exception. So you need to report that exception in terms of this, or else you need to handle that in a try catch block. Okay. So here I am using join method. See, there is my thread T is new my thread of, that is T is my child thread. On T I just called the start method, so it calls the run method, and T dot join. Actually, from here to here, this code is under the control of main thread. Okay, and I just created a thread child thread. So how many threads we have totally in this program? In between how many threads we are dealing? 2 threads. Very good. So as we are dealing with 2 threads, what I am telling is T dot join. Listen carefully. T dot join means T is what? T is what? T is a child thread. So on child thread, until unless the child thread completes, the main thread should not interfere. The main thread should not interfere on the in between while executing the child thread. Okay, just listen carefully. T, that is until unless the child thread completes its execution, the main thread will not interfere in between. Understood? No, that is what join operation. That is what join operation. Okay. Now, listen. Let me execute this so that you'll understand. See what happens actually. Child thread executed for how many times? Child thread executed. Child and then main. Child finished first because join method called on the child object. So the child thread finished first, and then only the chance will be given to the main thread. Okay. And one more thing. Why it is pausing for? Why it is pausing? Because I just used a sleep method of half second. Okay, and also it is printing. The child thread statement is printing for 10 times. 10 times. Okay, understood? No, understood everyone? Let me execute once again. Let me execute once again. See. So the join method on which I called the join method, that thread will complete first, and then the chance will be given to the other thread next. Okay, that is what join. Listen very carefully and remember this in your mind. Okay, right. Did you understand everybody what is join method? Yes or no? Yeah. Now listen. Now we are dealing with the yield method. Yield method is what? Yielding. Yielding means voluntarily I am giving my control to the others. Voluntarily I am giving my control to others. Suppose I am a thread. Okay, I am a thread. Suppose I am a high priority thread. Okay, so as I am a high priority thread, of course the thread scheduler is inspired by your priority. So it is giving always priority to, it is giving always chance to the high priority thread. Then if there is if there is a second thread which is of a low priority thread, maybe priority is 1 or 2 or 3. Okay, so the low priority thread will never get a chance. The low priority thread will never get a chance when in the case of sometimes if it is giving priority importance to the priority. So what happens is the higher priority thread, that is I am voluntarily giving my control, giving my CPU to the others, to the CPU, to the other thread which is still waiting for the execution. Okay, that is what yield method. I already shown you that life cycle. So whenever I call a yield method, from running state to again it comes back to which state? If you clearly observe the figure, I don't want to show you the figure right now. You just tell me. Runnable, very good. Whenever I call the yield method, so the control will be from the running thread will be snatched away and given to the low priority thread which is under waiting. Okay, so it will come again to runnable, not to the block. Understood? No, it will not comes to the block state, but it will again come to the runnable pool and wait for its execution again. Okay, guys, are you able to follow me? Are you able to follow what is yield method? Okay, voluntarily giving its control to the other threads. Okay. So, but I'm telling you guys, this yield method, of course I used yield method, but the thread scheduler will respect this yield method or not, we don't know. Understood what I'm saying? Of course I'll say I just want to give my control to the others, but the thread scheduler may respect you or not, we don't know. Okay, so that is listen carefully, listen very carefully. See, in there are my thread class. There is a my thread class and also demo 7. In demo 7, I have a main method and also my thread m is equal to new my thread of, that is m is my child thread. Okay, and on m I'm just calling the start method, so it calls the run method which is there in the thread class. Okay, and this code is under the control of main method. And listen carefully that in the run method I just have a loop from 0 to 0 to less than 10 means 9. What I'm doing is I'm just printing the child thread and number, but whenever I is equal to 5, whenever I is equal to 5, I'm just yielding, that is thread dot yield. Then what happens, as we discussed right now, this yield method, that is the child method, has to give its control to the whichever the second thread, in this case main thread. Actually it has to give, but it may give or may not give. The thread scheduler may respect your statement or not, we don't know. It may or may not. So let me execute this. Understood now? Did you understand what is yield method? Yes. Execute. Let me execute this so that. But you should not. Worry about this. This yield method, because it is like that only. Okay. You need to remember that thread scheduler may or may not give preference to your yield method. See, actually here child thread is 5. Here child thread is equal to I is equal to 5. But of course here it has given chance to the main thread. Okay, it has given chance because of yield method, or it was given automatically, we don't know. But if I execute once again, here also it was happened. Here also it has happened. It was happened. Sometimes, okay, sometimes, always this cannot be expected. Always this cannot be. See here, child thread 5, and again the control will be given to again child thread only, no? Understood? Understood or not? So the thread scheduler may or may not give preference to your yield method. Sometimes it has given in these cases, but sometimes it may not, like this. Okay, understood? But join method is working. Join method, it is working as the thread scheduler is respecting your join method, and it is following that. Okay. Understood now what is yield method, guys? What is yield method? Did everybody understood or not? See, now we are entering into the most important concept, that synchronization. Synchronization. Okay, synchronization. Okay. See, what is synchronization? Did we discuss any synchronization before? We have discussed a couple of times, no? At the time of string buffer and string builder. So we have discussed, no? Then tell me, what is synchronized? What is synchronization? To allow only one thread to access this. Very good. Excellent. Excellent. That is to, what's your name? 6W? What's your name? Thread safety. Shaker. Very good, Shaker. See, so whenever there is a shared resource, I am specifying that shared resource. Shared means, suppose there is a shared resource, maybe a method, maybe an object, maybe one of the object, any resource which is shared by multiple threads, then the concept comes synchronization. Then only the concept comes synchronization. Otherwise, synchronization is not required. Yes or no? If there are separate objects and on each object separate threads are working, then what is the use of synchronization? Yes or no? Of course, can you realize? So whenever there is a shared resource only, then only we have a concept called synchronization, because that shared resource is shared between multiple threads. Okay, listen. So this program where two threads process the same resource, unsynchronized process. Here we are looking at the unsynchronized process. Have a look at this. Here, how many classes we have? There is a class display class in which I am having wish method. Okay, and there is a class my thread class which is extended from thread class. So this is a thread class, and here I am having a look at this. I am having a constructor and I am having a run method. I am having a constructor and I am having a run method. And in the main method, what I am doing is I am just display d is equal to new display of. I am just creating an object for the display. I am just creating an object for the display class. So D is my object. D is my object of type display class. Okay. Now, how many threads I have been created here? How many threads we have created? Two threads, T1 and T2. And new thread of what we are passing here? Can you please tell me what we are passing? The display object. D is what actually? D is the display object and also the name. So at this statement, what is going to be called automatically? At this statement, what is going to be called automatically? It's a thread creation, no? Constructor. This constructor is going to be called automatically. Yes or no? This constructor is going to be called automatically. Okay. So with this, in this constructor, what I am doing, this thread object is assigned with the display object and also the name. అండర్స్టూడ్ నో ఒక థ్రెడ్ ఆబ్జెక్ట్ ఉంది ఆ థ్రెడ్ ఆబ్జెక్ట్ దేనికి అసైన్ అయ్యింది ఒక వాట్ ఆర్ ద అట్రిబ్యూట్స్ ఇట్ ఈస్ హ్యావింగ్ display object and also the name. Why I need display object actually? Why I need in thread object? Why I need to initialize display object? Because look at this very carefully. Run method. In run method, actually, whenever I say t1 dot start, which method is going to be called automatically? Which method is going to be called automatically? t1 dot start or t2 dot start? Start. Whenever I say start method, guys, everybody has to reply fast. Of course you know, but you have to reply again. Only 2 students understood the run method is going to be called. What about the remaining? Are you and only 3 letters? No, you need to type. Okay. See, whenever I say t1 dot start or t2 dot start, the run method is going to be called. And in the run method, which method I am calling actually? Wish method. Yes or no? It's a wish method. So as it is the wish method I am calling, actually wish method is in which class? Wish method is in which class? Can you please type for quickly? Display class. So as it is there in the display class, if I want to call the wish method, do I need its object? Did I require its object? Yes, obviously. Yes, for sure. Yes or no? For sure we need to have. That is the reason to get that object, to call that method of the other class, I am just initializing the display object here. Okay, I am just passing the display object along with the name. So here, whenever I say t1 dot start, t2 dot start, which method is going to be executed? This run method is going to be executed. Yes or no? And can you observe this t1 and t2 both are working on the d object? Let me take the pen once. Actually, this is the D object. Okay, this is the D object D. Okay, so on this object, both the threads. What are the threads? Thread T1 and also thread T2. Both are working. So can I say This D object is the common object for both the threads. This D object is the common object for both the threads. Just a second. Hello, madam. Madam, ఇది క్లాస్లో ఉన్నాను, పర్లేదా? Guys, I need to leave for 10 minutes. Okay, it's an emergency. So shall I give you one task meanwhile? I'll give you a task that okay, is that okay? See, I'll give you this later. Okay, see, look at this task once. There is a program to find all subsets of a string. Okay, you need to find all the subsets. Okay, the input string is fun. Okay, and the input you have to take this string. Okay, and what you need to do is you need to find out the subsets. Subsets means f, fu, fun, u, un, n. Okay, initially f, and next fu, and next fun. Again the control comes from u, un, and n. So this is how you need to find out the subsets. Okay, for that reason you need to find out the length of the string, and you need to create one more array with this length. Actually, how many strings we are able to get? Suppose the length of the string is 3. How many subsets we will be getting? 3 n into n plus 1 by 2. That is 3 into 4 by 2. That is 12 by 2. That is 6. 6 substrings we will be getting. So the array you have to create with the length of n into n plus 1 by 2 like this. Okay, understood? And you need to take the two for loops. One is from 0 to less than n, and one more is from I plus 1 to n. One is from 0 to less than n, and one more for loop from 1 to n. Okay, so that within that for loop you need to use this substring method. Okay, which is taking two parameters, I comma j. Okay, understood? Okay, understood now, guys? Please do this program. Meanwhile, I'll be back very soon as possible. Okay, I'll just start the task. Yeah, please complete. Even other people also, other students also, please do complete. Okay, right. So where did we stop actually? Unsynchronization. Yeah, synchronization only, but this program is about unsynchronized process. That is a shared resource. This is our shared object. D is our shared object, which is shared between two threads. Okay, then how it is going to be? Of course, did you understand why did I use D object here? Why did I initialize that thread object with the D? Did everybody understood this? Yes? Yeah, fine. So let me, what output can you expect right now? T1.start. So it is calls the run method, and D.wish. What is the name I am passing with the thread 1? Sita. With the thread 2, Geeta. So it is a print. Good morning, Sita. Good morning, Geeta. Like that it has to print. Yes or no? Good morning, Sita, and good morning, Geeta for 10 times. Understood? See, let me execute this first quickly. How we are getting the output? As we expected, good morning Sita and good morning Geeta, like that we are getting. No, right? Actually, how we are getting? We are getting good morning. Yes or no? Understood? Is there any sequence? Is there any proper way to execute that method? Which method? See, both the threads are fighting. They both are interfering with each other. Okay. Suppose the thread 1 executed good morning here. The thread 2 meanwhile interrupted to print the name. Understood? The thread 2 interrupted again. The thread 1 had not finished the execution. Meanwhile, the thread 2 is interfering. Okay, understood now? Guys, are you able to understand the output in the unsynchronized process? Yes or no? Yes. Okay, fine, good. So, and now look at that carefully. Now I just want to show you one more. That is, now have a look at this. What is this right now? Just read the example. Read the example first. That is comment line first. Process synchronization example. This is previously unsynchronized process, but now it is synchronized example. Okay? See, the same thing. Everything is same. I'll replace this with okay. So I just replaced, there are two threads and everything is same. Now what happened, what actually in an unsynchronized example, did you observe the which method is now, what is this method now? What is this method right now? What is this method right now? What type of method it is? Synchronized method. Yes or no? Now the which method is of type synchronized method. By using the keyword synchronized, I can make the which method as synchronized. So what happened? Now on that particular object, now on that object D, there would be a lock. There would be a lock on its monitor. Okay, understood? So as the lock is created, only one thread can able to execute at a single time. Only one thread can able to execute at a single time. Okay, understood now? Understood. So meanwhile, the other thread will not interfere until unless it completes its execution. One thread is enter into this wish method. The other thread T2 will not interfere. When the T2 is executing, T1 will not be interfere. Understood? So let me execute quickly. Now what happened? Is the other thread T2 is interfering in between? Is Shravya interfering in between while Jahnavi is executing? Yes? No, not at all. Because why it is? Why? What is the reason? The reason is the concept is synchronized. The object is locked because of synchronization, synchronized keyword. Understood? Understood now? Okay. Yeah. Okay. Next one. This is what synchronized block. Actually, this example belongs to synchronized block. Synchronized block means actually, see, the same thing. The main method is same. We have created two things. Everything is same. The display, thread class also same, and the display method is also same. Guys, one thing I want to ask you. I'll ask you after this explanation. Okay. See, this is what synchronized block. From here to here, this is called synchronized block. Okay. What is this synchronized block? Suppose there is a method. Suppose there is a method which is having 100 statements. Which is having 100 statements. In that entire method, I don't want to log the entire method, but I want to log a particular statements in that method. Only a couple of statements I want to log. So what I am going to do is I'll make this as that is synchronized. I will keep the statements in synchronized block. I'll keep the statements in the synchronized block. And why synchronized of this? This I need to pass. This means the current thread. I am passing the current object. Okay. The method is called on whichever the object that I am passing here. This is always what? This is always what? This refers to current object. So whatever the current object I am calling this wish method, that object will be passed here. Okay. So whenever this block is going to be executed based on based on that object. Okay. Understood? So whenever we want to log a couple of statements in a particular method, then we will go for synchronized of this. Synchronized of this. Okay? Understood now? Is my voice breaking? Is it okay right now? Is it okay right now? Yes? Okay. Let me execute this. The same thing. So even synchronized block also is giving you the output in the same way, but because only a particular code I can able to block. Understood? Yes or no? Now I will ask you a question. That guys, didn't you get any doubt that instead of calling that object, instead of calling that wish method which is there in another class, instead of calling the wish method which is there in another class, couldn't I write any that logic here itself, that wish method here itself, that logic here itself? We can write. Can we write? Think a little. Yes? I said no. Because, listen very carefully. Suppose if I write this entire code, suppose this is the code I want to log now. So if I cut this code and if I paste here, what happens if I paste here? Then what happens? I need to log that particular code now. I need to keep a lock on that code now. For that reason, which method I need to declare as the synchronized right now? If I paste that code here, suppose, think, imagine. Then which method I need to make as synchronized? Run method. Listen carefully. So, can I declare run method as synchronized? Because run method actually, whose method actually is this? Run method actually our method is it belongs to the my thread or is thread class? Actually, this run method is belongs to which class? Thread class, that is super class, parents class method. Okay, so the parent class method I am using here. The parent class method I am using here. Okay, then can you please tell me what is the concept of this? What is this concept called? When I am using a method of my parent class, then the concept is What will you call if you are using your parent class method? Ah, exactly, Rohit. That is not inheritance. Of course, inheritance. In inheritance, we will do that. That is not overloading, Rohit. Not overloading. It's not overloading. Very good, Shekhar. It is overriding. Overriding because whenever I am using the same method of my parent class in the derived class, this is the derived class now. If I am extending, my thread అనేది derived class కదమ్మా. derived class లో నా పేరెంట్ క్లాస్ మెథడ్ అనే రన్ మెథడ్ ని నేను యూజ్ చేస్తున్నాను అంటే is it not overriding? It's an overriding method. Run is an overriding method. It's not belongs to the derived class exclusively. I'm just overriding. Okay. So, do you know the rules of overriding? Do you know the rules of overriding? What are the rules? The signature, the prototype of the method has to be same as your parent class method. I couldn't even change. I couldn't write anything here synchronized. I couldn't write because if I write like this, what happens? The method, the prototype of this method will change now. The prototype of this method will change now. The signature of the method changes now. Then will it be overriding then? If the signature changes, will it be overriding? No, not at all. Yes or no? Then this run method will not be executed. The thread concept will not be executed. Understood? Understood or not? What I am saying? So that is the reason I couldn't keep that particular code here. I couldn't make this run method as synchronized. I cannot. So what I am doing, I just maintained one separate class and I just maintained a separate method and I am calling that method. I just declared that method as synchronized and I am calling that method and the run method. That is fine. I can call the synchronized method under run method, but I cannot make the run method as, I cannot declare the run method as synchronized. Did you understand the logic, everybody? Can you able to recollect the overriding concept? Guys, yes or no? I cannot change the signature of the method when I am overriding. Understood? Right. Very good. Excellent. So that is the reason I just do this. One more thing I'll tell you. Suppose if the method is static, public synchronized void, public synchronized void wish method. If I make this method as static method, okay, then do I require this object to call this method? Do I require this object to call this method? Do I require? For a static method, do I need any object to call? No. Yes or no? Because static methods are the properties of static methods ever property. They belongs to whom? Class. Very good. They belongs to class actually. They doesn't belongs to any one single object. So I don't require any object. If the method is static, if the method wish method is static, if I declare this as static, I don't require this. I don't require this. I don't require this. This also. And I don't even require this also. And I did not require object to call this method. Understood, everybody? Understood or not? You can make a static method also as synchronized. Hope you understood this concept. Yes or no? Yeah? Clear? Right. So that is what the last and final one is I'm going to tell you is inter-thread communication. Guys, listen very carefully. Inter-thread communication. Okay? This is the last concept actually. This is the last concept. Okay. See. Yeah, are you ready to listen? The last one. I'll close this thing within 5 minutes. 5 minutes, I'll close this concept. Yeah, be ready. So, let me take the pen. Actually, what is inter-thread communication is, the inter-thread communication. That is, suppose there are multiple threads working on in my program, how communication is provided between the threads. Okay, that is what inter-thread communication. Okay, synchronization, what it is going to do, it locks a particular object so that one thread at a time is going to execute. But they are not communicating with each other. Did you find that? Did you observe that? They are not at all communicating with each other. Okay, understood now? But in the synchronized context itself, I can provide some communication. How the communication is? Listen very carefully. Suppose there is a buffer. Suppose I think this is a shelf. Maybe this is a shelf. This is a shelf. Suppose think the shelf which is there in your wall. Okay, one shelf is there. Every time, suppose mother is keeping something which is some eatable in the mother is keeping some eatable in the shelf to eat. Okay, and the child will come and he has to consume that eatable which is there in the, suppose maybe it is a laddu. Think that it is a laddu. Okay, the child has to consume it. Okay, whenever after the mother keeps something in the shelf. Okay, until unless the child consumes one laddu, the mother will not keep one more laddu in the shelf. Okay, that is what the rule you have to keep in your mind. Okay, understood? Until unless the mother keep one laddu in the shelf, the child couldn't consume anything in that. Understood? Understood, everyone? Yes or no? So there is a communication between the mother and the child that the mother has to produce, then only the child has to consume. Until unless the child has to consume, the mother will not produce, will not keep anything in the shelf. Okay? Did you understand this context? Okay? Yes. I'll change a little. Okay. What I'm doing is, now in our programming context, I'll keep that it is as a buffer. This is a buffer. That is some storage. Buffer. This is buffer. Okay. Buffer B. The object, the buffer name is B. Okay. This is B. Now there is a producer. There is a thread, two threads working on the same common object. I am always telling you, the buffer is the common object between two threads. Yes, like a producer and consumer problem. Now, this buffer is the common object between two threads. The two threads are producer. This is producer. Suppose, please bear with my writing. Producer, and this is consumer. Okay. Oh, sorry. It's okay. So this is consumer. So the producer will produce some item in the buffer. Then only the consumer has to consume that item. Okay. Until unless the producer produces, the consumer will not consume. Okay. Understood now? Understood? See, in this context, what you have to see is, look at this very carefully. Look at this. There is a class called buffer. Okay. In this class, I have a variable A and also some boolean flag, produced flag, which is initially set to false. Listen very carefully, guys. I just vaccinated, so I'm feeling somewhat giddiness I'm getting. Okay. But please be attentive while I'm teaching, because only after I'll take only 5 minutes. Okay. See, there is a value A and there is a flag, which is a flag, boolean flag, which is initially set to false. Okay. Now I'll change this. Guys, are you listening now? Are you listening? Because I'm not getting anything from you. Okay. Yes, are you listening? Very good. Then I'll this is A. In buffer, what we are having? This is A. Okay, this is A. A is a value of the buffer, and there is a flag, produced flag. This is initially set to what? This is initially set to what? False. Very good. Initially false. Right. See, what happens is, there is a method, listen carefully. In this buffer class, what else we have? There is a produce method. There is a produce method, which is a synchronized method. And also there is a, I'll tell you what is there in produce method later, a bit later. And also consume method, which is also a synchronized method. Okay. And still what else we have in this program? There is a thread, producer thread, which extends from thread. Okay. And also there is a consumer thread, which extends from thread. Okay. Right. And also there is a test class, which is there in the main, which is the main method is there. Okay. And listen carefully. I just created an object here. Is it not object creation? Buffer B. Buffer B is equal to new buffer of. Okay. Right. And here I am just creating a producer thread by passing the buffer object. By passing the buffer object B. And also I am creating a consumer thread by passing the same buffer object B. It is not B1. The same buffer object I am passing. Yes or no? I am passing the same buffer object. That means the buffer is the common resource, common shareable object between producer and the consumer. Okay? Understood? So far? Now I am starting the threads. P dot start, C dot start. So as I said, P dot start and C dot start, what is going to happen? Whenever I use this, whenever I do this, the constructor is going to be called. Producer constructor is going to be called. Yes or no? Producer constructor is going to be called, and that producer is initialized with the buffer object. In next, this statement, consumer statement. The constructor of the consumer is going to be called, and this is also be, and this the buffer object is assigned to the consumer thread. Okay, still here did you understand? Now what happens is, P dot start, suppose producer starts first, then the run method of the producer, where is the run method? This run method is going to be executed. So what is there in the run method? So it has to call in the run method, producer start producing. How it is producing? Okay, I'll tell you right now, and I'll come to the program. As initially the flag is F no. Initially the flag is F no. What does it mean? There is nothing in the buffer. F means what? There is nothing in the buffer. So whenever the producer checks the flag is set to false, then the producer understands there is nothing in the buffer. So he produced one item in the buffer. Okay, understood? And what it is going to do is, it is going to set the flag as true. After producing, the producer set the flag as true. Okay, understood? Understood or not? Till now? Till now, understood or not? Now, again the consumer comes. Again, next time, suppose the consumer comes. The control will be given to consumer. The consumer comes to the buffer and it checks the flag. It is set to true. It is set to true. So the consumer understands, as the buffer set to true, there is an item to be consumed. There is an item in the buffer to be consumed. So it consumes that item. It consumes that item. Okay, that item, and set the flag to, and it consumed, and set the flag to what? Set the flag to, after consuming, it set to false. Very good. It's set to false. Okay. So again, if the producer comes, Then again the producer checks the flag, so it is set to false. So it produces one more item in the buffer. Okay, but now listen carefully. After producing the item, it set the flags to what? The producer sets the flag to what? Again sets the flag to true. Okay, right. Now what happens is, I don't know. Again, after producer, the consumer has to come. I don't know. There is no guarantee. No. Till now we have seen. We cannot expect the consumer has to come after producing. Suppose the producer may comes once again. Listen carefully. The producer, multi producer thread call in anukondi. What happens? Again, the producer comes to this and checks whether the checks the flag. Initially, it checks the flag. So the flag is T. So what happens? As it is having the flag T, so that it calls the wait. It cannot produce one more item now, because the item already there in the flag, there in the buffer. Okay, very good, Shravya. Already set to true. So true means something is there in the buffer, so it will not produce once again. So the producer calls the wait method. The producer calls the wait method. Okay, the producer calls the wait method. So as soon as the wait method calls, what you will understand? Wait method will get your thread from running to which state? Which state? Block state. Okay, there is some states no in your thread life cycle. So on the producer thread calls the wait method, it will enter into from running to block state. So as the producer is in the block state, what happens? The other thread will get the chance. So the consumer will go to that buffer and checks the flag. Of course, it is true. So it is consumed. The item is consumed by the consumer and sets the flag to false. Okay, understood now, and sets the flag to false and then notifies and calls notify method. Notify method, what it is going to do is, it notifies the other thread which is there in the block state. Already block state lo evaru unnaru? Which method is there in the block state? Block state lo evaru unnaramma? Producer. So that producer get notification that as soon as the producer received the notification from the consumer, it comes back to the again from block state to runnable, that is ready to run, from block state to runnable. Okay, and it waits. So what happens? Okay, it waits in the runnable. So runnable state lo ippudu evaru unnaru? Producer and also consumer. Then suppose again consumer calls. Then what happens? Consumer, what it is going to do? It goes to the buffer and checks the flag. Of course it is F. Of course it is wait false. So again it calls the wait. Very good, Shravya. Excellent. It calls the wait method. Again consumer calls the wait method. Okay. As soon as it calls the wait method, this consumer goes into the which state? Block state. Very good. Block state. So what thread will get the chance right now? The producer will get the chance. Yes or no? So the producer comes to the buffer and produced one item and sets the flag to from true to false to true. Okay, understood now? Set the flag to false to true and notify and calls the notify. So notify method will notify whom? Notify whom? Consumer, which is there in block state. Guys, are you listening? Only Shravya is responding. Where are the other guys? Listening, no, everybody has to reply, yeah, at least yes, yes. Okay, yeah, okay, understood. Very good. So this is how the communication will be developed between the producer thread and the consumer thread. Did you understand when the wait method is going to be called and when the notify method is going to be called? Yes or no? Yes? Yes. Did you understand this entire context? Right? Now we will come back to the program. So, as it calls the produce method, where is the produce method? The produce method, which is there in the buffer class. So, this method calls. So, what is there in the produce method? Initially, what is the flag actually? Initially, in the starting, false. Initially, I set the flag to false. I'll set. Don't worry. Okay. Initially false. So what happens? It is false. If for false, so will this enter into this code? No, right? Yes. So it will not enter into that code, and so a is equal to x. That is, the a value is to be assigned with the value whichever I want to produce. Okay, understood? Now, what statement I am printing? Product 1 is produced. Maybe 1. The value is 1. Product 1 is produced. And after producing, what I have to do? What the producer has to do? It has to set the flag to true, no? Yes? True. And then notify. And then calls the notify. Notify actually, initially, suppose maybe their consumer already block state lo undemo. Okay. Consumer already block state lo undemo. So that the consumer will notify, so that the consumer will get a chance. So how this consumer will get a chance? If of not produced, that is actually the after producing, what is my flag? True, no? Let me set that true first. Let me set that to true. Okay. So if not of true means false. So will I enter into this code? Will I enter into this? No, never. So what happens? Product A is consumed. 1 is consumed, and again the consumer has to set the flag to false, and also it calls the notify. Now, once again I'll tell you, listen carefully. Suppose again the consumer set the flag. Let me set the flag. Please let me set the flag to false. This is consumed. This item is consumed, and set the flag to false. Okay. Now it is false. Suppose the consumer calls once again. Instead of producer, the consumer called once again. Then what happens? The consumer called. If of not produced, not of false. What does it mean? Not of false. Into this code, no? Yes. Blocks. Right now, the consumer is went to block state now. So sorry. Yeah, is my voice okay right now? Is my voice okay? Clear? Yes. Please let only 2 minutes. Okay. So wait అనగానే కన్స్యూమర్ ఎక్కడికి వెళ్ళిపోయింది? బ్లాక్ స్టేట్ లోకి వెళ్ళిపోయింది. సో until unless the producer called once again and sets the flag to true, produced and sets the flag to true and calls the notify, then only the consumer again comes into the picture. Understood? Okay, so the producer came and also let me do this and produced something. Where is that? Produced something in the buffer and also sets the flag to true. Now again the producer comes to again the producer called. Again the producer called. What happens? What happens? If of true, what does it mean? I'll enter into this code. Yes or no? Yes or no? So the producer is waiting. So it has to call the wait method. So as it calls the wait method, the producer goes into the block state. Block state. Okay. Until unless the consumer comes and calls the notify method, consumed and calls the notify method, that producer will not come into the again runnable pool. Understood, everybody? How the consumer and how the producer and the consumer are communicating with each other? How the inter-thread communication happens? Guys, my battery is low, so let me start the task first. Okay. Just a second, guys. Just a second. Have to print -1. If it is valid 1, you have to. If it is not valid, you have to print -1. And the constraints you have to consider is the minimum length of the password is 6 and the maximum length is 15. Okay, and it should have minimum of 1 capital letter, 1 digit, and 1 special symbol. That is, what are the special symbols are allowed? Only asterisk, @ and also #. Okay, only these 2 conditions you need to keep that in your 3 conditions. One is the length, one more is 1 capital letter, 1 digit, 1 special symbol. Okay, and the special symbols are all only asterisk, @ and #. Okay, suppose here it is, it fulfills all the things. So I am printing 1. Okay, explanation, it has 1 capital letter, 1 digit, 1 special symbol. So the length of the string is also 8 characters. So it is between the range. So what happens? I am printing 1. Then what is the case in second case? Why I am printing -1? Why I am getting the output -1? What is the reason? Can you please tell me? It doesn't have any capital letter. Okay, it doesn't have any capital letter. So can you do this program? Will you try? Okay. Okay, yes or no? Or do I need to explain the code also? What do you say? You just try. If you couldn't understand, I will explain in the next class for sure. But please do try. Okay. Let me start the task. You have to finish both the tasks, guys. Okay.